Good afternoon, everyone. Today's class we are discussing about string efficiency. So, what is string? The ratio between potential across the string to the product of number of disks and potential across the disk, which is near to the conductor. The ratio between potential across the string to the product of number of disks and potential across the disk, which is near to the conductor. That is, string efficiency is equal to the potential across the string divided by the product of number of disks which is near to the conductor. That is, number of disks means n, or flashover voltage of the string, flash flashover voltage of the string to n into flashover voltage of the disk which is near to the conductor, where n is the number of disks consisting in the string. So n is the number of strings consisting in the string. So what is flashover voltage? The voltage at which a flashover occurs across the string. An arc is developed between the line conductor and earth tower or pole. That is wet flashover voltage at which a flashover occurs across the string under wet condition. Here it is that there is two types of flashover voltage, that is wet flashover voltage and dry flashover voltage. Wet flashover is nothing but a voltage at which a flashover occurs across the string under wet condition. Dry flashover voltage at which a flashover voltage occurs across the string under dry condition. The puncture, the voltage at which current passes through the cap to pin in a suspension insulator. The voltage at which the current passes through the cap to pin in a suspension insulator. Then the insulator acts as a conductor. It is completely damaged. So when the insulator breaks, the insulator acts as a conductor. So short circuit will occur. So we are discussing the problems on string efficiency. A string of suspension insulator consists of 3 units. A string of suspension insulator consists of 3 units. A string of suspension insulator consists of 3 units. The potential across the first and second insulator, the potential across the first and second insulator are 9.35 kV and 12.2 kV respectively. The potential across the first and second insulator are 9.35 kV and 12.2 kV respectively. Calculate the line voltage. Calculate the line voltage ratio of capacitance between pin ion to self capacitance of each disk. Ratio of capacitance between pin ion to self capacitance of each disk. And string efficiency. So first we have to read the problem carefully. So here the volt suspension type insulator consisting of 3 units. And 3 units is nothing but the voltages at which the capacitance is 3, that is E1, E2, E3 the three capacitors will be connecting here, and the first and the potential across the first and second insulators are 9.35 kV and 12.2 kV. See here the given data is the potential across the disk 1 is E1, that is equal to 9.35 volts. The capacitance across the voltage E1, E2, E3 here MC. The potential across the disk 1 is potential across disk 1 is E1 is equal to 9.35 kV, and similarly E2 is equal to 12.2 kV. And naturally what is the formula for second insulator, that is E is equal to E2 is equal to E1 into 1 plus K. E2 is equal to E1 into 1 plus K, or 1 plus 1 by M, K equal to 1 by M. That is 12.2 is equal to 9.35 into 1 plus K. 12.2 is equal to 9.35 into 1 plus K. So from this we have to find the value of K, that is 12.2 is equal to 9.35 into 1, 9.35 plus 9.35 into K. So that is 12.2 minus 9.35 is equal to 9.35 K. So that is K is equal to 12.2 minus 9.35 divided by 9.35. So K is equal to 1.3048. K is equal to 1.3048. So 1 plus K is equal to 1.3048. K is equal to 1 minus 0.38, that is 0.3048. K equal to 0.3048, and K equal to 1 by M. K equal to 1 by M, that is mutual capacitance C1 by C. So similarly E3 is equal to E1 into 1 plus 3K plus K square. Similarly E3 is equal to E1 into 1 plus 3K plus K square. So that is E1 is equal to 9.35 into 1 plus 3 into 0.3048 plus 0.3048 whole square. Substitute the value of E1 K value, that is 9.35 into 1 plus 3 into 0.3048 plus 0.3048 whole square. That is 9.35 into 1 plus multiply with 3, that is 0.9144 plus 0.3048 whole square, that is 0.0929. That is equal to 18.768 kV. 18.768. E3 value is 18.768 kV. But actually E3 is equal to 18.768. So we know the value of E1 and similarly E2 and E3. Now we have to find the value of total E phase, that is equal to E phase is equal to E1 plus E2 plus E3. So that is 9.35 plus 12.2 plus 18.768 is equal to 40.318 kV. This 40.318 kV. So now we have to find the value of first line voltage. Line voltage is equal to EL is equal to root 3 into E phase. We have to find the value of line voltage, that is EL is equal to root 3 into E phase, that is equal to root 3 into 440.318 kV. So we get the value of line voltage, that is equal to 69.83 kV. Similarly, we have to find the value of string efficiency. Already we are finding the second one, the ratio of capacitance between pin to self capacitance, K. We have to find the value of K, right? So next, K equal to 0.3048, and next, string efficiency is equal to, what is the definition for string efficiency? E phase efficiency is equal to E phase into number of discs into voltage accorded maximum voltage. This, what is E phase, is nothing but 40.318, number of discs is 3, and the E3 is 18.768. So efficiency is equal to 71.6%. So E phase value is 40.318, and N is the number of discs. So already the problem is given. The given 3 units. So number of discs is 3, and E3 is 18.768. That is equal to 0.718, 716, that is 71.6%. The next problem is a 33 kV, a 33 kV 3-phase overhead line is supported on a string of 3 similar insulators. The mutual capacitance of which is 10 times the shunt capacitance. Mutual capacitance is 10 times the shunt capacitance between the unit and earth framework. Between the unit and earth framework. Calculate the first one, voltage across each insulator. That is E1, E2, E3, and the efficiency and the string efficiency. So first we have to read the problem. Here the 33 kV is nothing but line voltage. A 3-phase overhead line is supported on a string of 3 similar insulators. That is, number of insulators is 3. The mutual capacitance of which is nothing but 10 times the shunt capacitance. So K is equal to C by C1. K is equal to C by C1. So C is equal to nothing but K into C1. So K is equal to C by C1, and C, we have to find the value of C. C is equal to 10 into C1, shunt capacitance between the unit side, which is frame of earth framework, and calculate the voltage across each insulator and the string efficiency. So there is a condition is for capacitance, the mutual capacitance of which 10 times the shunt capacitance. Mutual capacitance is equal to 10 times of shunt capacitance. So actually we know the formula. K is equal to, so the line voltage EL is equal to 33 kV, and the mutual capacitance is equal to 10 times the shunt capacitance. Shunt capacitance is C1, mutual capacitance is 10 into C1. So we have to find the value of K is equal to C by C1 by mutual capacitance, C1 by C, shunt capacitance by mutual capacitance. the number of insulators is 3. So we have to find the value of K is equal to shunt capacitance by mutual capacitance. That is shunt capacitance C1, mutual capacitance is the condition is 10 times of the shunt capacitance. So K is equal to 1 by 10, that is equal to 0.1. So phase voltage E phase is equal to EL by root 3. EL is nothing but 33 kV. 33 kV by root 3, 19.053 kV. E phase is equal to 19.0. So E phase is equal to E1 plus total voltage, that is E1 plus E2 plus E3. So E1 is nothing but E1, E2 is nothing but E1 into 1 plus 1 by 1 plus K, plus E3 is equal to E1 into 1 plus 3K plus K. So substitute the value of E1. So from this we have to find the value of E1. So E phase is nothing but 19.053. E1 we have to find the value of E1. So E1 into K, E1 into 3K plus E1 into K square. So substitute the value of K. So that is E 3.41, E1 19.052. So E1 is equal to 19.052 divided by 3.41. So E1 is equal to 19.053 by 5.587 kV. So this is only. So we have to find the value of voltage across each insulator. So we have to find the value of E1, but similarly we have to find the value of E2 is equal to E1 into 1 plus K. E2 is equal to E1 into 1 plus K. 5.587 into 1 plus 0.1. That is E2 is equal to, that is 6.146. E2 is equal to 6.146. Similarly E3 is equal to, so E1 into 1 plus 3K plus K square R. So we have already formula that is E1 is equal to E1 plus E2 plus E3. So from both the formulas we have to find the value of E3. E3 is nothing but E phase minus E1 minus E2, that is 7.32 kV. 7.32 kV. So voltage across the each insulator is over. Similarly string efficiency. String efficiency is nothing but efficiency is equal to E phase by number of discs into E3. Maximum voltage is E3. So that is equal to 19.053 by 3 into 7.2. So we get the value of 0.86. That is 86.76 percentage. So efficiency is in percentage, that is 86 into 86 percentage. String efficiency is E phase by N into E3. This 19.053 into 3 into 7.32. So next, that is 0.86. So 0.8676, that is 86.6. Next problem is a string efficiency, a string insulator. Third problem, a string insulators with 4 discs. The capacitance of the disc is 10 times the capacitance between the pin to earth. That is, calculate the voltage across each disk when it is used on 66 kV 66 kV line. Also calculate the string efficiency. A string insulator with 4 disks, right? The capacitance of the disk is 10 times the capacitance between the pin to earth. Pin to earth is nothing but shunt capacitance. That is, disk 10 times the 10 times mutual capacitance is 10 times the shunt capacitance. That is, C is equal to 10 into C1. Calculate the voltage across each disk when used on 66 kV line. 66 kV line is nothing but line voltage is 66 kV. Also calculate the string efficiency. Same problems. Calculate the voltage across each disk. So that is, the line voltage is EL is equal to 66 kV. The mutual capacitance is equal to C into shunt capacitance. So we have to find the value of directly K. So we have to find the C1 is equal to 10 into C1. So we have to find the value of K. K is nothing but C1 by C, shunt capacitance by mutual capacitance. C1 by C, shunt capacitance by mutual capacitance. Mutual capacitance is nothing but shunt capacitance of pin to earth, and mutual capacitance is insulator to inverter. C1 by 10 into C1. So C gets cancelled. Here K is equal to same, that is 0.1. So similarly, E phase voltage is equal to root EL by root 3. Right? E phase is equal to EL by root 3. EL is nothing but 66 by root 3, that is equal to 38.106 kV. So E phase is equal to EL by root 3, that is 66 by root 3. So we have formula, that is, E phase is nothing but E phase is equal to E1 plus E2 plus E3. Here the string insulator 4 disks, that is E1 plus E2 plus E3 plus E4. So here that is E phase is equal to E4 plus E3 plus E2 plus E1. So substitute the formula, that is, E phase is equal to E1. E2 is nothing but E1 into 1 plus K. E3 is equal to E1 into 1 plus 3K plus K square, plus E4 is nothing but E1 into 1 plus 6K plus 5K square plus K cube. Right? 1 plus 6K plus 5K square plus K cube. So substitute the value of 5K, K value, that is 0.1. So E phase is nothing but 38.106. So we get the value of E1. So that is, E1 is equal to 4 plus solving the equation, that is 4 plus 10K plus 6K square plus K cube. So that is, E1 is equal to 38.106. E phase is equal to 38.106, that is equal to E1 into 4 plus 10 into 0.1 1 plus 6 into K square, that is 0.1 whole square plus 0.1 whole cube. So that is, E1 value is that 38.106 is equal to 38.106 is equal to E1 into 4 plus 1 plus 0.06 plus 0.001. So we get the value of E1. E1 is equal to 38.106 by 5.061. 5.061. So that is equal to, E1 is equal to 7.529 kV. 7.529 kV. So substitute the value in E2. E2 is nothing but E1 into 1 plus K. So that is 7.529 into 1 plus 0.1. So E2 is equal to same, that is 7.529 into 1.1, that is equal to 8.282 kV. Similarly, E3 is equal to E1 into 1 plus 3k plus k square. So substitute the value. E3 is equal to E1 into 1 plus 3k plus k square, that is E1 is equal to 7.529 1 plus 3 into 0.1 plus 0.1 whole square. So that is 7.59 into 1.31, that is equal to 9.863 kV. 9.863 kV. So from this E4 we have to find the value of E4 is equal to E phase minus E1 minus E2 minus E3, or E4 is equal to direct formula. E4 is equal to E1 into 1 plus 6k plus 5k square plus k cube. So substitute the value of form, or directly E4 is equal to E phase minus E1 minus E2 minus E3. So 12.43 kV. So E4 is equal to 12.53 kV. 12.43 kV. Right. So we have to find the value of string efficiency. So voltage across by each disk is over, that is E1, E2, E3, E4, and we have to find the value of string efficiency. Efficiency is nothing but E phase by number of disks into maximum disk voltage, that is E4. That is E phase is 38.106 by number of disks is 4 into E4, maximum voltage disk is E4. E4 is nothing but 12.43 kV. 12.43 kV, that is equal to 0.7664, that is equal to 76.64 percentage. So the string efficiency for this conductor is 76.64. So that is string efficiency is equal to E phase by N into E4, that is 38.106 by 12.4, that is 0.7664, that is equal to 76.64 percentage. So in this class we have discussed about the potential across each insulator, the developed an equation of string efficiency, flashover voltage and puncture, and different problems on string efficiency and the number of voltage across the each disk. We have done different problems on voltage across the each disk and string efficiency. So these are the different problems, that is to calculate the maximum voltage that a string of two suspension insulators can withstand. Calculate the maximum voltage that a string of two suspension insulators can withstand. The maximum voltage for each insulator is not to exceed 18 kV. So the maximum insulator's voltage is not to exceed the 18 kV. The capacitance between shunt is 20% of the mutual capacitance. 20% is nothing but, that is 20 by 100, that is equal to 0.2. The capacitance between the shunt is mutual of capacitance. So here we have to find the value of maximum voltage. So that is E1, E2. Maximum voltage of each insulator is not to exceed 18 volts. The capacitance between the shunt is, so first we have to find the value of E1. E1 is equal to shunt capacitance to mutual capacitance is K equal to 20%. 20% is nothing but 20 by 100, that is equal to 0.2. So we have to find the value of E1 is equal to, so maximum voltage for each insulator is not to exceed 18 kV. So E2 is equal to, they have only 18 kV. E2 is equal to, so E1 is equal to, E2 is equal to E1 into 1 plus k. So we have to find the value of E1. E18 is equal to E1 into 1 plus 0.2, that is 1.2. So E1 is equal to 18 by 1.2. Right. Next, each line of a three-phase system is supported by a string of three similar disks. So here not to exceed 18 kV is nothing but the phase voltage is 18 kV. Right. Next, each line of three-phase system is suspended by a string of three similar disks, that is three insulators. The voltage across the line unit is 17.5 kV. Calculate the line to neutral voltage, that is E phase value. Assume that the shunt capacitance is 0.125 of the mutual capacitance. I'll find the efficiency. Here three insulators, the voltage across the line unit is 7.5 kV. So E1 is given, and calculate the E phase. Assume that the shunt capacitance is 0.125. The mutual capacitance, also find the efficiency. So next, a string of four suspension insulators is connected across a 285 kV line. The mutual capacitance is 5 times the shunt capacitance. Calculate the potential across each unit, the string efficiency. Right. So a string of four suspension insulators is connected across a 285 kV line. That is, line voltage is 285 kV line, and the mutual capacitance is 5 times the shunt capacitance. So K is 1 by 5, 0.25, 0.4, that is 0.2. K is equal to 0.2. Calculate the potential across each unit, the voltage across each unit, that is E1, E2, E3, E4, and the string efficiency. String efficiency formula is E phase by number of disks. N is 4 into E phase, that is maximum voltage, that is E4. E phase by N into E4. So we get the string efficiency. So in this class we are discussing about different problems on string efficiency. So once again I am discussing here what is string efficiency. String efficiency is nothing but the ratio between potential across the string to the product of number of disks and potential across the disk which is near to the conductor. So which is near to the conductor is nothing but we have maximum voltage. So that is, number of conductors is more, the near to the conductor is maximum. So that is E1 is one conductor having the tower having three conductors, so maximum voltage will be E3. So the ratio between the potential across the string to the product of the number of disks and potential across the disk which is near to the conductor, that is equal formula. String efficiency is equal to potential across the string by number of disks N into potential across the disk which is near to the conductor. Potential across the string is nothing but that is E phase line, E phase voltage by number of disks N into potential across the disk which is near to the conductor. Or flashover voltage of the string. Flashover is nothing but the voltage across the maximum bearing capacity of the conductor, that is flashover of the string, by n into flashover voltage of the disc which is near to the conductor, that is maximum voltage of the disc. So n is the number of discs consisting in the string. That is flashover voltage. A voltage at which a flashover occurs across the string, an arc is developed between the line connected to earth tower. So voltage at which a flashover occurs across the string, an arc developed between the line conductor and earth tower. So wet flashover and dry flashover. The wet flashover means voltage at which a flashover occurs across the string under wet conditions in sunny days. So dry flashover in rainy season. The dry flashover voltage means voltage at which a flashover occurs across the string under dry condition, that is in summer, so it will be very dry. It is puncture. The voltage at which the current passes through the cap to a pin in a suspension insulator. So voltage at which the current passes through the cap to pin in a suspension insulators. Then the insulator acts as the conductor and it is completely damaged. So the insulator acts as the conductor, it is completely damaged. So voltage at which the current passes through the cap to pin in a suspension insulator, the insulator acts as a conductor, so it is completely damaged. That means short circuit occurs to the pole. So here the different problems. So the potential across the string of suspension insulator consists of 3 units. That is 3 units is nothing but the number of discs in the discs is 3. The potential across the first and second insulators are 9.35 kV and 12.2 kV respectively, and to calculate the line voltage, the ratio of capacitance between the pin and self capacitance. So here I am explaining one more problem. Each conductor of a 33 kV three-phase system is suspended by a string of the 3 similar insulators, the mutual capacitance of which across units is 9 times the shunt capacitance between unit and earth framework. Calculate the voltage across each conductor of 33 kV. Each conductor of 33 kV three-phase system is suspended by a string of 3 similar insulators, the mutual capacitance of which across the units is 9 times the shunt capacitance between the unit and earth framework. So calculate the voltage across each insulator. So here the line voltage is 33 kV, that is we have to convert the phase voltage VL by root 3, right? So mutual capacitance is 9 times the shunt capacitance. So 9 times the shunt capacitance. So K is equal to 1 by 9. K equal to 1 by 9. So we have to find the values of, calculate the voltage across each insulators, that is E1, E2, E3, E4. So what is E1? E1 is directly E1. So E2 is nothing but E2 is equal to E1 into 1 plus M. So 1 plus K. E2 is equal to E1 into 1 plus K. So E3 is equal to E1 into 1 plus 3K plus K square. 1 plus 3K plus K square. And similarly, so we have to find the value of E phase is equal to E1 plus E2 plus E3, because it is containing only 3 similar insulators, that is E is equal to E1 is equal to E2, E is equal to E phase is equal to E1 plus E2 plus E3. So substitute the values in E phase, so we get the values of E1. Similarly E1, E2, E3. So we are calculating the voltage across the each capacitance. String efficiency is nothing but string efficiency is equal to E phase by number of discs into near to the conductor. So voltage across the number of conductors is 3 here. So E phase is equal to N into E3. So in this class we are discussing about different problems on string efficiency, right, and flashover voltage and function. Okay, thank you.